Let's discuss more examples on how to factor difference of squares. Here, factor x squared minus 25. Do we have a GCF? None. Do we have two terms? Yes. Is the first term perfect square? Yes. The exponent is even. Is the second term a perfect square? Yes, because we can write this as 5 squared. Do we have a subtraction? Yes. Alright, so the factors will be like this. So the first term in each factor will be x, and then the second term on each factor will be your 5. Next example. Do we have a GCF? None. Two terms? Yes. First term a perfect square? Yes, because the exponent is even, and we can write x4 as x squared raised to 2. Second term a perfect square? Yes, because we can write 64 as 8 squared. Do we have subtraction? Yes. So our factors will look like this. So the first term of each factor will be x squared, and the second term of each factor will be 8. In this case, I have x squared minus 8. Now let's check if we can use DOS to further factor x squared minus 8. Is the first term perfect? Yes. Is the second term a perfect square? No, 8 is not a perfect square. Therefore, there's no way for us to further factor x squared minus 8. So, we are confident to say that this will be the final answer. Let's factor 49 minus x squared. Do we have a GCF? None. Do we have two terms? Yes. First term a perfect square? Yes, because we can write 49 as 7 squared. Second term a perfect square? Yes, because the exponent is 2. Do we have a subtraction? Yes. Alright, so we can now apply DOS. The factors will look like this. So the first term in each factor will be 7, and the second term in each factor will be x. Next example, 36 minus x squared. So do we have a GCF? None. Two terms? Yes. First term a perfect square? Yes, because 36 is 6 squared. Second term a perfect square? Yes. Do we have a subtraction? Yes. So the factors will look like this. The first term of each factor will be 6, and the second term of each factor will be x. Okay, factor 25 x squared minus 16. Alright, do we have a GCF? None. Two terms? Yes. First term a perfect square? Yes, because we can write 25x squared as 5 squared x squared, or 5x quantity squared. Is the second term a perfect square? Yes, because we can write 16 as 4 squared, y4. Now we can write this further as 4y squared squared. So this one is the same thing as this, because 4 raised to 2 is 4 squared, and y raised to 2 is y4. Now do we have subtraction? Yes. So the factors will look like this. The first term of each factor will be 5x, and the second term of each factor will be 4y squared. 49x squared minus 1. Do we have a GCF? No, we don't have a GCF. Two terms? Yes. First term a perfect square? Yes, because 49 can be written as 7 squared x squared, and this one is just 7x squared. Second term a perfect square? Yes, 1 is a perfect square. Do we have a subtraction? Yes, we do. Okay, so the factors will look like this. The first term of each factor will be 7x, and the second term of each factor will be equal to 1. Okay, next example, 3a squared minus 75. Do we have a GCF? Yes, we have a GCF. Our GCF here is 3. So we can factor out 3 right now. We're going to get 3 times a squared minus 25. Now let's check the expression inside the parentheses if we have a DOS. Do we still have a GCF here? None. Do we have two terms? Yes. First term a perfect square? Yes. Is the second term a perfect square? Yes, because we can write 25 as 5 squared. Do we have a subtraction? Yes, we do. Okay, so the factors will look like this. 3 times a quantity times a quantity. So the first term on each parenthesis will be a, and the second term in each parenthesis will be 5. So this will be the complete factorization of 3a squared minus 75. Alright, next example, 2x squared minus 18. Do we have a GCF? Yes, we do. We can factor out 2 here, so we're going to get 2 times the quantity x squared minus 9. Now let's check the expression inside the parentheses. Do we have two terms? Yes, we do. Is the first term perfect? Yes, it is perfect square. Is the second term a perfect square? Yes, because we can write 9 as 3 squared. Do we have a subtraction? Yes, we do. Alright, so the factors will look like this. The first term in each parenthesis will be x, and the second term in each parenthesis will be 3. Next, 32x squared minus 18m squared. Do we have a GCF? Yes, we do. We can factor out 2. So we'll have 2 times 16x squared minus 9m squared. Or let's try to check if the expression inside the parentheses will be a DOS. Do we have a GCF here? Okay, none. Do we have two terms? Yes, we do. Is the first term a perfect square? Yes, because we can write 16x squared as 4x squared. Is the second term a perfect square? Yes, because we can write 9m squared as 3m squared. Do we have a subtraction? Yes, we do. So the factors will look like this. So don't forget to bring down your 2. So the first term on each parenthesis will be 4x, and the second term on each parenthesis, or the second term in each parenthesis, will be 3m. Next, 8x squared minus 72y squared. Do we have a GCF? Now again, if you can't really find a GCF right away, try to use our ladder method, wherein think of a number that can divide 8 and 72. We can start by 2. This is 4. That's 36. Now I think we know that both numbers can be divided by 4. So we'll get 1 here, and that's 9. So your GCF here will be 2 times 4, which is equal to 8. So bring out your 8. You'll get 8x. We'll get x squared minus 9y squared. Inside the parentheses, let's check if we have a DOS. Do we have two terms? Yes, we do. Is the first term a perfect square? Yes. Is the second term a perfect square? Yes, because we can write this as 3y quantity squared. Do we have a subtraction? Yes. Okay, so when you write the factors, do not forget to bring down your 8. So the factors will look like 8 times the quantity times the quantity. So the first expression in each quantity will be x, and then the second expression in each quantity will be 3y. Okay, next example. So we have s4x squared plus 4x squared. Okay, let's check if we have a GCF. It seems like x squared is a common factor, so we can bring out x squared. So we have a GCF here, which is x squared. Bring out x squared. We'll get x squared quantity s4 plus 4. Now let's check the expression inside the parentheses if we can use DOS. Do we have two terms? Yes. Okay, the first term is a perfect square. The second term is also a perfect square, but we don't have a subtraction. Therefore, I cannot apply difference of two squares here. So this will be our final answer. X squared times S4 plus 4. Px squared minus Pm squared. Do we have a GCF? So P is a common factor. We can bring out our P. So we have x squared minus m squared. Do we have two terms? We have two terms inside the parentheses. Is the first term a perfect square? Yes. Is the second term a perfect square? Yes. Do we have a subtraction in between? Yes. So we can use DOS for the expression inside the parentheses. So your factors will look like this. P times the quantity times the quantity. So the first term in each quantity will be x, and the second term in each quantity will be m.